Good afternoon, folks. Today we're going to be talking about scatter plots. Um, scatter plots and prediction equations. Okay? Data with two variables, such as a year and number of visitors, okay, are called bivariate data. So an example of that maybe in the year 2016, how many visitors were there at the St. Louis Arches? Okay? That would be bivariate data. It has two variables, the year, number of visitors. A set of bivariate data graphed as ordered pairs in a coordinate plane is called a scatter plot or dot plot. Okay, so scatter plots. There's a couple different types here. There's positive correlation. You see, okay, positive correlation, and you see data. The slope of the line is positive, and the points are close to the line. Okay, you can clearly see that data is kind of related there with positive correlation. Okay, there's also negative correlation. Okay, you plot all the points, all the visitors, all the year. Okay, and there's maybe negative correlation. There's a line that clearly fits that data. Okay, and it has a negative slope, so that would be negative correlation. There's also data that has absolutely no correlation. Okay. So when you find a line that closely approximates a set of data, you are finding a line of fit for the data. An equation of such a line is often called a prediction equation. Because it can be used to predict one of the variables given the other variable. And we're going to look at prediction equations today. So that's kind of the main point of this lesson. Plotting points, okay, plotting ordered pairs. You guys should be very familiar with that. So we're worried a little more about the prediction equation. So real world example 1 here. The table shows the percent of U.S. households with internet access. That's by year. Okay, so this is bivariate. One of the variables being the year. Okay, year is one of the variables. We'll call that our x variable. And the percentage being the other variable, so that'll be our y. So make a scatter plot and a line of fit and describe the correlation. Let x be the number of years like we had and since 1995. So we've got to go ahead and make this a coordinate plane here. And this is our x-axis. Okay, this is our y-axis. So it looks like we need to start about 15%. We go up 10 each time. 35, 45, 55, and 65. Okay. Get a little scrunched up there, so I'll be able to fit that 55 and 65 up there. That'll be all right. And then number of years on our x coordinate here. Things are going to be to scale the number of years since 1995. So 2, 4, 6, 8, 10. All right. So x, this is our years since 5. Y is percent of households with internet access percent. Okay. So we're just plotting points. The point 1997 with the percent 18%. Okay, so 1997, that's 2 years after 1995. So we're going to 2 on our x. And we're going to go up to 18. So that's between 15 and 25 there. Okay. It looks like in the year 2000, so that'd be 5 years after 1995. 2000 is 5 years after 1995. And the percent household jumped up to all the way to 41% there. Okay. And then we've got in 2001, so that's 6 years after 1995. And we've got 50%, so it's a little bit higher here. Okay, so between our 45 and 55 line there. And 2008, that's 8 years after, and we've got 54.7. And 2007, that's 12 years after, we've got 61%. Okay, so you can kind of see this data is obviously linear, and it's got some sort of correlation to these data points. As the years move on since 1995, okay, more houses have been rent. That makes sense. That's true. All right, so use two ordered pairs to write a prediction equation. So here, the ordered pairs we're going to want to use, 5 and 41.5. That's that point there. I'm going to highlight that in red, actually. We'll use that. Code. So that's the point we want to use. That's the 5, 41.5. And in blue, we'll highlight the other point. We're going to use 12 and 6. That's our last one. And I'll highlight that in blue. Okay. So we're going to use those 2 points to find the equation of a line, okay, a prediction line. Why we use those 2 points, okay? If you were to draw ourselves a line here, I'm going to use black again. If we were to draw ourselves a line through those 2 points, okay? That fits the data. Okay, there's a point below it, a couple of points above it. So it fits the data. It kind of captures all points. A couple above and a couple below. Okay, so that's the idea here with our prediction equation. Just so happens it gives us these 2 points we're going to use. Okay. So first thing we need to find the slope of this line and this prediction equation. And that's going to be y2 minus y1 over x2 minus x1. So let's just call this y2, x1, y1. So this is something we should be familiar with. Y2, 61.7 minus 31.5 over x2, 12 minus 5. So simplifying that, I'm going to get 61.7 minus 41.5. Okay, that's going to give us 20.2 over 12 minus 5, 7. Okay, 20.2 divided by 7. So simplify to 2.8. 2.89. Okay, and again, this was percent households already. We're looking at percent over time, over years. Okay, it looks like 2.89% a year. That's how much this is increasing. How many more people have internet access? That's not our prediction equation, though. Now we need to, use a point, use our point slope form. We have a slope. We have an m value for this line. Now we need to use one of these points, our point slope, which is y minus y1 equals m times x plus x1. All right, so y minus, we're going to use the same y1.41.5 is equal to our slope, 2.89 times x minus 5. Okay, we have to do a little bit of distribution here. 89x minus 5 times 2.89. It is 14.45. Great. Okay. Need to add 41.5 to both sides. So this y is equal to 2.89 x and 41.5 to negative 14.45. So you get positive 27.05. Okay, and that is our prediction equation. Okay, again, to summarize, we picked 2 points that kind of best fit the data. Okay, we picked those 2 points. I have a point below and a couple of points above there. We found the slope using these 2 points, and then we wrote the equation of the line using these 2 points. Okay, and that's our prediction equation. So why is this useful? So now say if we wanted to go and find in the year 20, let's say this year, 2017, okay? In the year 2017, what percent of households will have internet access? I'll abbreviate there. You know what we're talking about. All right, so if we wanted to find this, we could. Okay, 2017 is how many years from 1995? 22 years. So substituting in for x, we've got y equals, that's going to be our percentage, 2.89 times 22 years plus 27.05. This should give us a pretty rough estimate. 90.63% of households would have internet access in this year, according to this problem. And 90.63%, that's a rough estimate. Yeah. Wonder how accurate that is. Oh, I guess our next question is to predict the number of households with internet access in 2020. So I'll leave this one to you guys. Okay, I'll leave this one to you. You can go ahead. 2020 would be how many years from 1995? Should be 25 years. So go ahead, plug in 25 years. Plug that into our x value there, into our prediction equation. We should be able to find what percentage of households have it. That is y. So after you've paused and done this, okay, we come back, we got y equals 2.89 is our slope. We're substituting 25 years. And we're adding, what was that number? That number was 27.05. 27.05 is our value. Okay, so 2.89 times 25 plus 27.05. Using my calculator here. 99% of households should have 99.3%. 99.3% should have internet access in 2020. Okay. So that's something to look out for. See if that's true. Man, that format's all messed up here today. First time doing this. There we go. Hopefully we're all set up. The table shows the mean selling price of a new privately owned single-family homes for 6 consecutive years. We'll make a scatter plot and a line of fit. So I'll let you guys try this one on your own. Okay. You try this on your own. So pause. Go ahead. Try to do this. All right. So if you're rejoining me, the scatter plot, we're going to identify x and y here. Okay. I use time on my x a lot. So time. We're going to go from 0 to 1, 2, 3, 4, 5. Okay. Measure 5 consecutive years. And then we're going to price in the thousands. Okay, so this is years. And this is price. Units is $1,000. So 154.5. That's $154,500. Okay. And we need to go from 154 to 273. So let's maybe count up by 25. So 150, 175, 2, 2 1/4, 250, all the way up here to 275. Excuse me. All right, and that's price in hundreds or in thousands of dollars. Okay. So now we should need to plot points 0, 154.5. That's going to be just above 150 on the y-axis there. 166. That's going to just be over here. 1 again, just above 50, between 50 and 175. 2 and 181.9. So that'll be above our 175. Between that and 200. 3, that's going to be above our 200. Too much though. 4 and 228, so it'll be above our 225. And then 5 and 273.5. It'll be up here really close to that 275. Wow, so that is really pretty linear. Very positive correlation you can see there. So this is a positive, we need to describe the correlation. This is a positive correlation. So it should have a positive slope. The line of benefit. So a prediction equation. We need to pick a couple points that best fit the data. I think I'm going to go with this point here. We just need to pick 2. So I'm going to pick 1, 166.4. And I'll highlight the other one here in red. I'll pick this point, which is 4, 228.7. So I'm picking 2 points. I picked those 2. They look like we drew a pretty straight line there. Yeah, not going crooked anyway. But we drew a pretty straight line there. That's kind of a line of best fit. All right. So if you pick 2 other points, our answer should be pretty similar still. Okay. We need to go again find ourselves a slope. So let's go 166.4 minus 228.7 over 1 minus 4. It's going to simplify. This is going to give us our slope. And that's negative 62.3 over negative 3. 20.7, 20.8 round. Okay, so 20.8 is our slope. Now we need to use our slope in one of our points with our point slope form. Our slope form, y minus y1 equals m times x minus x1. So choose one of the points. I'm going to choose 1 and 166.4. Smaller numbers, a little less scary, right? So y minus 166.4 equals m 20.8 times x minus 1. So y minus 166.4 equals 20.8 x minus 20.8. Add 166.4 to both sides. This gives y equals 20.8x plus calculator over here, 145.6. And that is our prediction equation. Predict the selling price of a new home for year 8. So here we want to plug in year and x value. So this is x equals 8. We're substituting in here. So let me scroll a little bit. Y equals 20.8 times 8 plus 145.6. So let's see. Year 8, what a house cost. 20.8 times 8. 6. It's going to get $312,000. So that'll be 3. Y equals 312, so that's 300. And in our units, price is in thousand. So it's $312,000. Wow. So let's see. So how accurate does your prediction appear to be? All right, so the values of homes, what this means, the slope, 20.8, that means what's that mean? Think about what that means. Okay, if our slope is 20.8, that means the value of homes is increasing. Okay, our X value yearly, so home is increasing yearly by $20,000, $20,800 by $20,000 per year. Is that insane? Right now, I would say that doesn't make a whole lot of sense. It doesn't appear to be very accurate. Okay, actually, home prices have dropped since 2008 at least. They might be bouncing back a little bit now. So I don't think they're increasing at that rate. That they would be buying homes. This was the case. So that concludes our notes for the day. Hopefully this was helpful. Have a good afternoon.